Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host Shafu, and today's episode is with Jango from Juicebox. So, Jango, thanks for taking the time, man.
Hey, thanks for having me. Happy to be here. This is fun. I love talking about the nitty-gritty of what makes code bases special.
Awesome. Yeah, so Django is gonna walk us through the Juicebox Contracts v3. Um, so Django, why don't you briefly introduce yourself, introduce Juicebox, and then we can directly jump into the code.
Sure thing. Yeah. So Juicebox is a protocol that allows folks to program conditions according to which their project can receive funds. So, like, what happens when you receive funds, and under what conditions funds can be accessed from your project by yourself or from a community. And it's useful to create these patterns with familiar levers that can express relationships between producer and consumer, between one community member and another, between a customer and employee, an investor and an entrepreneur. And if we can reference similar patterns, then we can kind of create these networked projects that can talk to each other with financial rails that make sense and can wield a lot of power to share in a community effort. Um, Usually projects are community efforts that are taking in funds in one way or another. Um, and they are uh, very flexible. So right now we're kind of in the process of shaping this Juicebox language for like intentional competitive use. The very baseline of what Juicebox is just a flexible language for expressing these if this then that conditions that make up a project's finances. The original
Okay.
intent behind the project was to um, create a system where I can express upfront how much funds I need, and then I can accept payments into a project. And if there's funds over what I was intended um, to to raise in a particular time period, then everyone who helped me raise can essentially get a rebate on their initial price that they paid in to push everyone's price towards zero. The end result is I get what I needed, and everyone, the more people who paid, pay less. So everyone pays less, but we still fulfill the mission. This was a few years ago when I was prototyping and writing kind of the first version of this. And then a really inspiring community of developers has come through and really expanded the initial idea into something much more powerful and generic. And it's feeling like it's at a very stable place to now be used to build applications on top of, which is what the current uh, kind of topic du jour is how can we use these tools to build uh, powerful applications and express business models. So the V3 code base here is fairly large. There's a lot going on. So we're going to focus in on one particular contract that has the meat and potatoes of what it means to interact with Juicebox. If we're curious to learn more over time, feel free to reach out or poke around in the code base. But essentially, what we're going to be looking at mostly is this contract called the payment terminal, which is where when you pay a project, you're interacting directly with this contract. When you're and all the funds stay in this contract, so it's the one that has most like, concerns from a security perspective. If you're trying to access funds from your project, you're going to do it through this contract here. It's an abstract contract. It's called JB Payout Redemption Payment Terminal. and then 3.1.2 is the current version of this one. Basically, it's a generic JB payment terminal, which is the standard baseline component of how payment terminals are expressed via this very simple interface here. So to be a payment terminal in Juicebox world, all you need to do is implement a pay function, which is the function that folks are expected to call when they're trying to pay your project and have some reciprocal action take place. For instance, you pay my project and the project will mint, let's say, 1 million of its tokens and issue them back out to the payer. That's a very baseline Juicebox interaction. And so that kind of stuff will be implemented in pay. And you should also implement an add to balance function, which is I just want to deposit funds in a project but have no reciprocal action take place. And then there's some view functions here that you need to implement to let the outside world know if you're accepting a particular token, what the currency is for that token, how many decimals, etc. So very baseline, basic payment terminal functionality, and then there are layers of functionality we can add to this payment terminal to get to the contract we were looking at, which is a payout redemption payment terminal, which suggests, hey, we can also manage payouts from this. So once payments come in, you can now manage how those payments are leveraged. And then redemptions means there's also some functionality in here that allows token holders that receive tokens from, for example, from after having paid. So I pay 1 ETH to the project, I receive 1 million project tokens. I can burn the 1 million project tokens and receive the 1 ETH back, or some version of that rule set, depending on what the current redemption criteria is for the project. It's a yeah, go for it. Please jump in at any point.
Awesome. A question regarding the versioning system. So I see it is inheriting from 3.1.1. Why do it like this, and just why not use Git for versioning or something? Why keep track of the contracts like that?
Sure. Yeah. So the kind of core philosophy of how these things are architected is that anyone should be able to roll their own payment terminal at any point. Juicebox DAO is sponsoring the development of a few versions of these payment terminals, which are the canonical versions, which sites like Juicebox.money use. But if you are a project running on the protocol, you should have the ability to write your own payment terminal and then migrate your funds and operations from whatever payment terminals you're currently using into your terminals of choice. And so to take a step back in the architecture, I don't have a kind of clear diagram, full picture, but if we go kind of up the up the hierarchy of generic contracts, we get to this JB directory contract, which it has a simple mapping, for example, of a project ID, which is this 256 here, to an array of IJB payment terminals, which is that very baseline payment terminal implementation that folks are responsible for rolling if they're rolling their own. So from the JB directory, you can get a list of all the payment terminals that a project is currently accepting funds through. In the directory here, the project can set the terminals that they are accepting funds through, so the outside world knows, hey, I want to pay this project. I don't really care which terminals they're using. I just want to know that they, for instance, have an ETH payment terminal, right? So then I can go and get like where are we? The primary terminal of a project for ETH, for instance. And then independent of what payment terminal a project is using, it can resolve to the one I should pay, which gives us a lot of flexibility and gives projects flexibility to start somewhere that might be more convenient and then eventually evolve as their idea grows into something that needs something more proprietary for themselves. And so the versions that we've created ourselves here, they they're presented linearly because they are linear improvements. Like if you see 3.1.2, you should probably use that instead of 3.1.1 because it either has a slight kind of edge case tweak or introduces an amendment to like some data passing standard that maybe broadens functionality or something. But there are projects that are on all of these versions because they deployed then and they haven't migrated, and that's totally, or they deployed in a previous version, and the reason why Juicebox DAO created a subsequent version was for a reason unrelated to their project's operations, so they don't really care to migrate funds over and send that transaction. But in either case, if you go to the JB directory, you can kind of get a sense of which terminals project is currently accepting funds through, and projects have total freedom without Juicebox DAO's control or care as to which payment terminals they're operating under. If we go back to 3.1.2, just to quickly paint a little bit of a deeper picture here. There's a call to migrate. So here's like how functions are written and organized in this contract. So migrate project to another payment terminal, for instance. We're going to require permissions. So whoever's calling migrate has to either be the owner of the project, which means the address that owns the project's admin NFT. Each project on Juicebox is represented as an NFT. You can see that in JB Projects. JB Projects is a 721 votes. So every time you create a project, you're basically creating a new NFT in this contract, and whoever owns that NFT has that admin capacity. So in Migrate, only the project owner or someone who the project owner has given operator permissions to migrate terminal. So we have this operator standard where project owners can give any address, any number of permissions to do things on their behalf. And then we're going to do a really simple, just move funds from this contract into the destination contract and make sure the balances, the internal accounting is in check. And most payment terminals have this. It's not guaranteed since it's not in that core spec, but it's pretty standard in the ones that Juicebox DAO encourages folks to use, since we really want to make sure that we can evolve and that if any risks do appear, we do our best to test things thoroughly and audit things thoroughly and make sure things are safe and sound. But I think all developers know that things pop up sometimes seemingly out of nowhere, and we need to be very prepared to make decisions. And one of our like Juicebox DAO's principles is we aren't going to make decisions for you. Every project owner has total control over their funds, over their project. So the best we can do is suggest moves for you to make, but you have to send those transactions yourself as a project owner. Juicebox DAO is a project on the Juicebox protocol. It's a project with ID number 1. So it is also making these same decisions alongside everybody else. But this is the general migration idea behind what's going on. And we leave them all in the repo here to show that here's the progression. We don't intend for this list to grow infinitely long. The goal is to reach stability. Most of these versioning efforts were small edge case tweaks that we needed to improve to make the protocol more like guaranteed peace of mind for longer. All kind of feature additions or extensionality are made available through other hooks and whatnot, which hopefully we'll go through here in a bit and get to at least one of these core hooks. But in general, this is the idea.
Okay, Jango, one question. Payment terminals are still a little bit abstract to me. So could you maybe give a specific example why a project would have several payment terminals?
Totally. Yeah, that's a great question. So Most projects don't. Let's start here. Most projects have one payment terminal. Um, and I will actually go through this inheritance stack just to be clear. So a payment terminal, as we saw, the core payment terminal can accept any number of tokens, right? And just has to tell the world that it accepts it or it doesn't. Then we've scoped that down to this idea of a single token payment terminal, which is um, it's a payment terminal that essentially says, I have only one token. Here's how many decimals it uses. Here's the currency, and then in all those view functions that the core implementation needs, it just returns the fixed value. So now we've kind of scoped it down to one token. Now we've added all this other information, as we just saw, payout redemption. And then what we're going to do finally is we're going to introduce two things. We have a JB ETH payment terminal 3.1.2 and then a JB ERC20 payment terminal 3.1.2. This basically takes this abstract class and just implements how do I transfer in this particular token implementation. ERC20 has the same thing, but obviously transfers happen a little differently. And so the idea here is, though most projects currently only have one payment terminal, their ETH payment terminal, and the reason you'd want to have multiple payment terminals might just be to evolve from one to another. So maybe I start with one payment terminal, and then I switch to another, and then I switch to another, but I always just have one. What you can do at any point is you can add other payment terminals that accept different currencies into your payment terminal world. And these are all contracts that now hold your project's balances, which means if you're a community member of this project, i.e., you own the token of this project, a kind of core Juicebox principle is you should have access to the project's funds in some capacity, or rather, the project owner should be able to give token holders at least some access to the project's funds. And so having multiple payment terminals where you're receiving different kinds of tokens in makes it such that you can not only receive payments in those, but also I can burn my project's tokens, let's say, into the ETH payment terminal, but I can have the balances of any number of my payment terminals taken into account to determine how much funds from that ETH payment terminal I have a right to. So it kind of allows us to start to glue these things together while still giving folks with the token access to the full picture of what's going on.
Okay. Okay, so you have to loop over every token over every payment terminal. Is there like do you guys set a hard limit on the amount of terminals one project can have?
We do not set a hard limit. Anyone can essentially bring their own risks and opportunities in that sense. Um, like I said, everything that has been facilitated thus far has just been one payment terminal. So a lot of this is kind of designed such that we can't afford ourselves growth, and projects can afford themselves growth. You know, when I say we can afford ourselves growth, I mostly mean Juicebox DAO as project number one. But when we build for ourselves, we're kind of also building these capabilities for other projects going on. And a lot of folks in Juicebox DAO are also building other projects. So like hardly anybody's focused entirely just on Juicebox DAO. We're all building Juicebox DAO almost as a means to an end to create these set of tools that can empower other projects that we're working on. Um, but this is also kind of a thing that it's hard to find concrete examples because it hasn't been used yet. I think the end of this year we'll probably see a few new pockets of kind of opportunities and risks exposed from Juicebox DAO's end. We've been doing a lot of um, work in this contract component called the pay delegate, which is essentially a pocket of code that you can bring into your project that gets executed every time someone pays your project. So you can bring custom stuff. For instance, oh, if someone pays me uh, between point 0.1 and point 0.5, then do this extra thing, or only allow these addresses to pay during this time frame. So you can kind of bring custom components. We've been spending a lot more time supporting builds that kind of explore that little pocket of experimentation. But that's feeling pretty sturdy, pretty good. I think the next thing that folks are interested in are multi-terminal projects. So how can I accept stable coins as well as native tokens to a chain, and then also multi-chain as well. So how Juicebox DAO is thinking about multi-chain is less so like which chain do we want to be on, or do we want to roll our own chain, and more so like how can an organization, this abstract idea of an organization, exist across any number of chains while still maintaining the core value prop of its token being that it can access the total amount of what that project's value is, like the total amount across chains of what this project has at its disposal, what its total treasury is. So those two questions are really going to blow open this idea of what a payment terminal kind of is relative to a project. But for now, everyone just uses the JB ETH payment terminal. So a lot of these contracts, there aren't even folks sending funds through right now.
Okay, I got it.
Cool. So I think it'd be fun to do a deeper dive into how a payment works. How does that sound? So we can kind of just walk through a payment, and then I think that'll take up a good chunk of the hour. Maybe we can zip through, and if we do, then we'll do maybe a redemption call as well. But this is a good starting point for understanding how the protocol thinks about data structures and how the protocol makes certain choices and trade-offs.
Awesome, let's do it.
Cool. So this is the external call when you are trying to pay a project. This is one of those core must-haves in a baseline JB payment terminal. You specify which project's being paid. The payment terminal can be used by any number of projects. All values are kind of mapped to by projects. All funds are kind of stay in this contract for like across all projects. You can send the amount here, which gets overridden if you're sending ETH. So this again is an abstract contract that it works the same if you're sending ETH or ERC20s. So a lot of the stuff kind of here we see some pivots that depending, if you're not sending ETH, you have to transfer the ERC20 in. Otherwise, go ahead and just override the amount with the message value. You send the token here, but again, this is a single token payment terminal. It's just in the case of the ETH payment terminal, for instance, just takes ETH. So we're going to ignore the fact that you sent a token. It already knows what the token it expects is. The beneficiary is the address that you want to benefit from any reciprocal actions. Like if you're trying to mint an NFT or if you're trying to get tokens in return, they get sent to this beneficiary. Min tokens returned kind of gives some expectations. So the protocol may think it should send you X amount of tokens, but you're expecting a little less, a little more than X, and so the function would revert. This is a little nuanced property here. Each Juicebox project doesn't necessarily need ERC20 tokens, but each Juicebox project can account for fungible tokens. And it does so using an internal accounting mechanism that kind of makes each of these interactions a little cheaper, such that the pay function can be very cheap. It also makes deploying projects cheaper. If you don't need to deploy an ERC20, why don't you deploy a project? At any time after you deploy a project, you can mint an ERC20 token, and then folks that have balances can claim them into the ERC20 form. So this flag is just like if you make a payment and you're like, just give me the claimed version, give me the full ERC20 right out of the bat, even though it might cost me a little bit more gas for that operation. Otherwise, it'll just be stored and you can claim in batch later. And then some memos to send to the event and some metadata that gets forwarded to any extensions that the project rolls. So this is kind of a baseline payload that you'll see all over the place.
Question
Yes.
regarding the first line in the function that prevents unused var compiler and netspec complaints. This the oh, okay.
Yeah, it's like you can get rid of this and change netspec elsewhere, but it's common enough that we just kind of left it in.
Okay. The question I have, which I would find interesting, does this cost gas? Does it actually put token on the stack or something?
It does not. It does not. As far as I know, if someone has an inkling, if or kind of thinks it does, please let me know. But I'm fairly sure it's kind of been a while since we wrote it, but this was like a thing that we were considering for maybe like half a day, and then we were like, yeah, let's just do this because it makes it pretty explicit that it's not being used, and it doesn't cost gas. So that's just kind of a little solidity tidbit.
Okay.
Or maybe we're just silly and it does cost like too much gas for some odd reason, and everyone's been paying too much gas. So I don't know. Please inform us if we are weesh about this. Okay. So and then once it's normalized some stuff, depending on which tokens this terminal is responsible for coordinating, then we're going to go in and to this internal pay function.
Yeah, maybe interesting for some folks, Django, the balance before and the amount stuff. This is because some ERC20s take a fee or something in the middle, right?
Yeah, exactly. So again, this is a very generic abstract terminal, and we don't know which kind of tokens are going to implement it. This is just in case this transfer from is a virtual function in this abstract class that we saw how it was implemented earlier in ETH and ERC20. Anyone can roll another version of this that does something more clever and transfer from, like take a fee here or whatever. And so this balance before is just saying, I want to know how many tokens I have beforehand. I want to do the operation, and then I just want to overwrite the amount that was sent here to the exact difference. And then meanwhile, I want to send the amount into the transfer from so that it can actually happen accordingly. Under most cases, this isn't necessary, and you can just keep amount as is and go on. But this is like it's like all edge cases covered situation.
Yeah.
Good eye. So let's go into this internal pay function, which has all the good stuff in it. It takes basically the same stuff, so nothing new here. It's responsible for returning how many tokens the beneficiary got. Okay. I'm gonna go through line by line, and we'll talk about it. I think it's also the most important thing you should understand if you're either starting a Juicebox project or paying one is like what exactly happens. It makes sense to do this due diligence if you really care about the software you're using, and it's the real benefit of open source software is like you can never ask your bank for the line by line of what happens when you receive a payment or how it gets dispersed, but here we can talk about it out loud on calls like this, and it's amazing. So we do a tiny sanity check. We are one of those people who do the sanity check to make sure you're not sending an empty beneficiary on accident. a lot of people choose not to do this kind of check, which makes a lot of sense. You save some gas. But we do. The Because I mean, if you mess up something, usually the consequences are a little worse, and we do try to be somewhat helpful along the way and try to help folks not set up botched treasuries or botched payments. The core Juicebox data structure. So we've talked about the core Juicebox interaction point, which is the payment terminal. The core Juicebox data structure is a funding cycle. So every project is always in a funding cycle. You're never not in a funding cycle. And your funding cycles are either a fixed duration, meaning like a 14-day funding cycle, which means here I am in this funding cycle, and then 14 days later, I have an opportunity to change the configurations of my next funding cycle, but I can never change the current funding cycle I'm in. I'm always fixed for that funding cycle. Or I can be in a flexible one where I'm in a current funding cycle, but I can change it at any time to be in the next funding cycle. All a funding cycle is a set of rules. It's a data structure that encapsulates all of the rules that a project is currently abiding by. This includes how many tokens should be issued per unit of payment coming in. It includes how should redemptions work? Like how many tokens should I get in return if I burn a project token? It includes kind of all kinds of things. So we'll get to little points where we can see these things come out, but we want to get a reference to the project's current funding cycle so that we can kind of operate accordingly. And then we have some dreaded Stack Too Deep blocks. Shout out Stack Too Deep. Always praying to the Stack Too Deep gods, but hey, it worked. And then we are going to so here's kind of a tricky but maybe sensible thing to consider. I don't know if I can really rationalize it in kind of 5 minutes here, but I'll try. All the funds stay in the payment terminal, but each payment terminal has a payment terminal store, which isn't like a shopping store. It's like a storage store. It's like where the information is stored for this payment terminal. And in the store, we'll see where kind of balances are accounted for, and like all the actual kind of data gets stored. And in the payment terminal, it'll just receive payments and distribute payments accordingly. So the one big thing we want to do here is go to the store and record the payment. So record the payment from payer, how much was paid, which we bundled up here. Bundled amount is just the amount plus a bunch of context about what kind of token was being paid. Project ID, base weight currency. This is interesting. And it's definitely technical and in the weeds, but back on the note of multi-terminal, what base weight currency is imagine like I have an ETH payment terminal and it says, you give me an ETH, I give you 1 million project tokens back. And then imagine I also have a DAI payment terminal and it says, you give me 1 DAI and I give you 1 million tokens back. Those two terminals are incompatible because you get 1 million tokens back at very different rates. Because 1 DAI is not 1 ETH. And so let's consider a world where instead, the DAI payment terminal, although its main currency is DAI, its base weight currency can be ETH, such that if I pay 1 DAI into the terminal, I get 1 ETH's worth of DAI. I convert the currency into the base weight currency to determine how many tokens get issued out. So now I can have any number of terminals that take in any number of currencies, and they all can be normalized. So a token issuance, which uses this like token weight, this idea of a weight, all uses the same currency. So now I can actually distribute my project token fairly across any number of kind of token values So I just want to tell it the payment store what that base weight currency is for this terminal. Most terminals are just the same as the token that comes in because we're not dealing with this multi-token terminal world. And then all the other stuff. And what we expect in return is the funding cycle. So we're going to populate the funding cycle. We're going to populate the token count, which is how many tokens should I mint. Delegate allocations. This is an interesting one. It's an array of this data structure, pay delegate allocations, which I'm going to go to because this is where like things really get fun. Pay delegate allocations. There's three things here. There's a pay delegate, which is this address of this that conforms to this interface. There's an amount, and then there's some data that you send it. At IJB pay delegate 3.1.1 in this case. Pay delegate. It just has one function that you have to implement called did pay. So you can kind of get a sense. These are hooks. These are contracts that projects can add to their project that are attached to a funding cycle. So the hooks that apply at any time that someone pays during a funding cycle. And it has this did pay function. So what we're doing here is we are getting a reference to all of the hooks we want to call with reference to any amount we want to forward to those hooks from the incoming payment. So I can say, I'm getting this 1 ETH payment in, keep half of it, put it in the project's balance, and then the rest go and maybe invest it in all these like robo strategies or whatever. That all can be implemented to happen automatically through delegate allocations. And then if the store has a different memo or wants to override kind of the note that gets passed along to the event, it can. So once it has, and I think next step is to dive deeper into this record payment from transaction here. But I'm going to skip ahead and just power through the end of this top level pay function first. So after this, we're assuming that we have recorded what just happened. We know the information, the state has changed. So now we can actually do some outside world interacting. First thing we're going to do is decide, hey, do I have tokens to mint? If so, go to the controller. So each project has one controller. It can have any number of payment terminals, but it has only one controller. And you can go to the directory and find which controller the project is currently using. Again, you can migrate from controller to controller if you want to start somewhere and then evolve into your own set of rules or a set of rules that Juicebox DAO is recommending. But this is pretty stable. And you're going to tell the controller, mint tokens of this project ID. Here's how many. Here's to whom you should mint. And then that preferred claim tokens property shows up again to tell it if it should claim them if ERC20s exist or just keep them stored internally. And then this true flag here, which is a use reserved rate, which we'll go into at the end of this call if we have some time. But the idea here is each funding cycle, a project can specify a percent of newly issued tokens that are reserved for pre-programmed destinations. For instance, I can say, I can encode in my project's funding cycle, issue 1 million tokens per ETH coming in, 50% of tokens are reserved, split those 50% between me, you, and my great-grandfather or whatever, right? So like you can just have like a different kind of spread of tokens that get issued and distributed only when a payment is received. And so use reserved rate here saying this token count should take whatever the reserved rate of the funding cycle, of the current funding cycle into account. Those reserved tokens kind of get set aside, and then later anyone can call distribute reserve tokens, and then that'll actually take that set aside tokens and send them to the pre-programmed destinations. So cool. First thing we're going to do is pull that off. This is a pretty standard Juicebox thing. You don't have to issue tokens. You can always set your weight to 0. The weight is stored in the funding cycle. So if your weight is 0, you'll never issue tokens. It's all good. But tokens are useful because in case you want to give your payers access to a subset of funds now or into the future, it's nice to have tokens around to do that accounting, so you don't have to have the burden of management of airdrops and stuff like that. Everything in Juicebox world tries to prevent the burden of management. We try to kind of you set these projects in motion that you can have full control of if you own this project NFT, or you can pass the project NFT to a smart contract that kind of automates these rules for you, and then folks can kind of interact with either a refund mechanism trustlessly, or dividend mechanism trustlessly, or rebate mechanism trustlessly, or whatever you want to do. You can use these tokens for governance or whatever. You can decrease the tokens amount automatically each funding cycle. So you can say the current funding cycle issues 1 million, and then the next funding cycle has an issuance, or rather, the current funding cycle issues 1 million and it has an issuance reduction rate of 10%, which means the moment this funding cycle rolls over and the next funding cycle is active, it'll be distributing 10% fewer tokens for the same amount of ETH coming in. So you can have these rules that start to kind of incentivize those who come in earlier than later. But then the real extra power really comes from this idea of the delegate allocations, which are these custom bits that Juicebox doesn't roll for you, but you can bring your own. And Juicebox DAO has made a few that are fairly popular, like the NFT delegate. We call it 721 delegate, which basically says, in this did pay hook, I can check, hey, did I pay enough to mint this NFT that I want? If so, mint it and send it to the payer. And that's where kind of all this extra token magic happens. But this is kind of this token part up here, this ERC20, like more fungible, redeemable token, is more like baked in, more fundamental to the protocol, although it kind of functions in a similar way to just an extension and a hook. Here we'll do a very simple check to make sure that the expectation of how many tokens I got out match what I expected. So min return tokens, it should be greater than how many I actually got. And then we're going to do this fulfillment of the hooks. So if I do have delegate allocations, I'm going to package up a data structure with a bunch of context as to what's going on. I'm going to loop through all of these. I'm going to forward any funds I need to forward to the delegates. So any before transfer hooks to kind of do allowances and whatnot. And then I'm going to call the did pay hook with that data. So any delegates that do get called can now do their thing, knowing that all the other Juicebox functionality has already happened, all state has already changed, and here's a great place to revert if the conditions of the payment aren't solid, or do something extra like mint NFTs, or allocate portions of the funds to like robo DeFi strategies or whatever. And then lastly, we're going to emit an event. So this is kind of the skeleton of a pay sequence. And next step I'm going to do is the record payment from. We'll deep dive here, but I'll pause for questions if you have any.
Yeah, could you explain the delegate system a little bit more?
I'll do it. I'm going to do it through going into this function, because here, this
Okay.
function here is what returns delegate allocations. So here we're going to see how exactly delegate allocations are determined. All that this outside world needs to know as the manager of funds is that there are delegate allocations. And so Here we just want to fulfill them, but the curiosity makes a lot of sense because we have to know how the hell we got these in the first place. So let's dive into the payment terminal store, record payment from a transaction. Walking along this pretty big repo. For payment from. Okay. So here is the actual recording of information. It's slightly long, but not too long. We can probably step through this line by line again. So we take in information and we're expected to return the funding cycle, the project's current funding cycle, the amount of tokens we need to mint, delegate allocations, and a memo if we wish to overwrite the memo passed in. First thing we're going to do is go to the funding cycle store and get a reference to the current funding cycle of the project ID. Pretty straightforward. Funding cycle store is here. It's a contract that really cares about time and kind of rotations of this data structure. It always keeps track of the project's current funding cycle and any queued funding cycle, so any rule changes about to happen. That's all in funding cycle store. So if you're curious about how that works, that's where you check it out. It exposes the very convenient current of function where you can get the full data structure that currently applies for a project. We're going to make sure it exists, so the project is currently active. We're going to make sure that the funding cycle doesn't have a pay is paused flag on. Projects can set a current funding cycle to have pay paused, which means they shouldn't accept funds right now. So let's make sure that's not the case. We want to keep track of the weight. Remember, the weight is the measure that we want to mint tokens with. So if my weight is 1 million and I send 1 ETH in, I'm going to mint 1 million tokens. If my weight is 1 million and I send 2 ETH in, I'm going to mint 2 times the weight, so 2 times 1 million. So it's kind of just this normalizer here. And then we're going to do this little bit of a fancy thing here. This is really kind of the thing to grok about this function that makes from V2 Juicebox on different from V1. V1 of Juicebox didn't have this section here. It just had this. Essentially, the weight is baked into the funding cycle. So the funding cycle is going to set 1 million as my weight, and then it'll always mint 1 million tokens per ETH coming in. It'll always just pass along the same memo it received. But then we kind of realize projects might want to be more creative, either now or they want to afford themselves the ability to be more creative in a future funding cycle. So how is this structured? Funding cycles have an address called a data source. So a funding cycle can have a reference to a data source contract. And it also has a flag that says use data source for pay. So if a funding cycle has use data source for pay turned on, and if the funding cycle has a data source at all, what we're going to do is we're going to package up some context about the payment. And instead of providing the data ourselves, we're going to rely on this data source to give us the data we want. And the data source will provide us the weight, the memo, and any delegate allocations, which is the hooks that we were expecting. This store is going to assume the data source, which is just an address, is of type IJB funding cycle data source, and which has a pay params function. Pay params basically says, what are the params that I should be using when I receive a payment? Then I'm going to pass it a bunch of context here. So if you're implementing a Juicebox project, you have inevitably you have a funding cycle, which is a set of rules. In that funding cycle, you can lock in an address that every time you receive a payment, you're going to, the Juicebox protocol will go and ask that address, what are my pay params? So how many tokens am I minting? And are there any hooks I want to call after I have finished my normal routine? This is useful because you can do all kinds of fancy things here. You don't have to mint tokens linearly according to a hard-coded weight. You can mint different kinds of tokens depending on how much amount is being paid or who's paying or when the payment is coming in. You can do all kinds of things here. You can you can disregard these two and treat these normally and just send back an array of hooks that should be called later. So this is where you actually expose this first bit of extensionality to a Juicebox project. And then you can evolve your data sources on a funding cycle basis. So if you want to operate in the future with a different set of rules, you can always, the admin of the project can always reconfigure a future funding cycle.
Okay, so basically, I will try to summarize this. The difference between V1 and V2 is you can basically configure the weights however you want. It's like a dynamic thing.
Exactly. Yeah, you can configure the weights. So I'm going to go into the interface here. Pay params. There's two things. There's I can get data for pay params and I can get data for redeem params, but we just care about pay params here. I can configure the weight, and then I can also configure an array of hooks to call later. So the data source will also specify what kinds of hooks do I want to be called after all is said and done. So it needs to keep a reference to like an NFT contract that I should call the did pay hook later to. A common pattern that we see is people have the data source and the delegate as the same contract. So in pay params, I just maybe keep the same weight that was passed in, I keep the same memo that was passed in, and I just pass an array with a single item where address this is the only delegate allocation, which basically means, hey, just so you know, after you're done going through your normal routine, call my did pay function. And then later on in the implementation, we see did pay as a function that gets called. So it's the one place where you actually inject custom ideas into your pay routine. The amount of tokens as well as any special functionality, which can be open-ended. Again, you bring your own risks with this, but you also bring your own opportunities. So Juicebox DAO does develop some of these extensions that projects can use and clients can use, but projects are welcome to roll their own.
Okay.
Great. So we are going back to this block.
Yeah,
So let's
maybe
assume.
Jango, one last question.
Sure.
Line 271, wouldn't it be enough to just check if the address is zero or not and use that as a flag?
Yeah, you could, except for we only store one data source address in the funding cycles. All data in the funding cycle is packed very tightly. It all fits in one storage unit. So all these rules that you see lying around are all actually packed into one storage unit. And the data source it also has the ability to provide data for redemptions. So IJB funding cycle data source, it has the pay params as well as the redeem params. So there's a chance you're implementing a data source and you only want it to work on pay, but you don't want to have the redeem functionality on, in which case we have the flag there to specify that.
That makes total sense.
Cool. All right. So once we have all the delegates we want to do, here comes the actual accounting. Again, Stack Too Deep, shout out. So the first thing we want to do is, what's the difference of the balance that we expect? Well, the project had balance A. Initially, it got paid a certain amount, so it should have balance A plus amount.value. So we start with an assumption that balance diff is the amount paid in. If there are delegate allocations, we want to loop through them, and we want to decrement the balance diff if there are bits of this payment coming in that actually aren't going to affect the balance. They're just going to be forwarded on to the delegate. So the data source up here in delegate allocations specifies not only who gets called, which hooks get called, but also how much amount from this payment should be forwarded to those hooks. So here we just want to make sure that that's allowed, that we're not forwarding more than we just received. And then we only want to change the balance that applies. And then at that point, here, if there is a balance difference, we'll go ahead and decrement storage. This is our first interaction with storage, is just to decrement the balance. Up here, if the amount being passed in is 0, we can just skip everything that happens next. While also returning delegate allocation. So we need to do this check here to make sure we're not forwarding a disallowed amount. And then comes that weight bit with the base weight currency that I mentioned briefly. If there's no weight, then go ahead and return. We don't really care. 0 is passed as the weight, meaning there's no tokens to be minted. So 0 is the token count. If there is a weight, we want to make sure that the amount's currency is normalized to the base weight currency. We use an oracle to do that normalization if we need to, and then we'll set the token count as the amount value times the weight divided by this weight ratio. Shouts Paul, who you said you had recently on the call, for making an amazing math library, which we use extensively throughout the Juicebox protocol. Cool, so once we have done this math and storage magic, then we are fit to return to the main operation here, which we had already gone through, and then actually do the minting of tokens. So I think the next most cool and informative thing that we could do here is actually dive into this mint tokens call to see what happens when we mint tokens. How does that sound?
Let's do it.
Cool. We are going to step into JB controller 3.1. So notice we've gone through an original JB controller 3, and then 3.0.1 and 3.1. This was a very kind of delicate migration path that we did early on when we introduced v3, and it really proved out a lot of this kind of migration structure as necessary to avoid certain emergency situations, but also like we're very happy to be kind of stably at 3.1 as the status quo, and it works great. But if you want to look through the history of controllers, feel free to. They're all unchanged. The previous versions are unchanged. You can easily get to them. Mint tokens of. So what we're going to do here is the controller needs to know which project it's minting tokens for. Everyone, like many projects, can share the same controller. When a Juicebox project is deployed, there aren't any new contracts being deployed. You're basically just issuing that new NFT for somebody. So it makes those deploys pretty affordable, even on mainnet. So specify here the project that's being minted, the amount of tokens, who the tokens are for. If there's another memo you want to send to the event that provides context, that prefer claimed tokens flag, which we'll see how that works in here, and then that use reserved rate flag, which we'll also see how that works in here. A decently short function, but we'll step through it just to kind of give an idea. A large part here are permissions oriented, so we'll also do a detour and dive into permissions. Obviously we're expecting tokens to be minted. Otherwise, let's go ahead and exit out. Keep a reference to reserved rate, and then we are going to get the funding cycle's the project's current funding cycle. We've already done this once in the operation, so this should be a warmer fetch here. And we are going to check for the required permissions, because we don't want anybody to come here and be able to mint tokens for a project. We also don't necessarily want the project's owner to come in here and have full permission to mint tokens for their own project. Juicebox kind of tries to play this checks and balances game between project owner and token holders and other stakeholders in your project. So the project owner has to explicitly say up front that they have permission to mint tokens. Otherwise, there's an assumption that they don't, in which case we have to make sure here that a project owner cannot just mint tokens on their own. And we'll do this across these two blocks. So we'll first focus on this first block, require permission allowing override. So we're going to first do this require permission bit, which is what we saw earlier. Is this the project owner, or is this an operator specified by the project owner that has the mint operation permission? Either way there, we're good to go. Or we're going to allow override for terminals of the project. So if the contract calling this function is a terminal of the project, then we're also going to be A-OK, good to go. So this is a kind of a strong assumption here, is that a project's terminals can mint a project's tokens. So be very careful as to which terminals you add to the directory. That's because you're allowing them to control your project in many forms throughout the ecosystem. And then we're also going to allow the funding cycle's data source to also have this override permission, because if we recall, the data source is eventually going to be responsible for providing the token count, so it already can control how many tokens are minted. And so if it wants to serve also as a delegate that has some token managing routine, you don't need to configure a special operation to give your data source permission. There's an assumption that it can also control your project. So be careful which data sources you attach to your funding cycle. Don't just put your friend's address as your funding cycle's data source without knowing that they have kind of full control over your project's token issuance. Okay, so we came through here, but this also will pass if a project is if an owner of a project is calling this, and we don't necessarily want that. So there's a flag in the funding cycle called minting allowed, which if turned on, it means the owner has permission to mint from the mint tokens on demand discretionarily from this function. Its default false, so it has to be explicitly turned on. If it's not allowed and we're not receiving this call from a terminal or a data source, then we're also going to revert here, because the owner or the operator aren't allowed to make this permission call. So by default, the only entity that can call mint tokens of are the project's terminals. That's the moral of the story, which is what the case is here, right? We received a payment in the terminal, and the terminal is going to call mint tokens of for the project. And that's the default case. It's possible for the project owner to set in a current funding cycle a rule that allows them to mint, but they have to do that explicitly, and everyone knows that ahead of time as they're paying into the project, so that relationship is well known. Okay, that was a mouthful, but I think we got through the permissions. It's important to note how all the stuff kind of stitches together. It gives us an idea of the architecture here. We're now going to determine the reserved rate, which is that rate of token issuance that should be reserved and not issued out to the beneficiary. If that use reserved rate flag is true, then we're going to get the reserved rate from the funding cycle. Again, the reserved rate is a value that's set in stone for each funding cycle. So if you have a funding cycle that's 1,000,000 days long, it is the forever reserved rate. If it's just 2 days long, and then it means this reserve rate can change if the project owner chooses to send that reconfiguration. But in any case, the current funding cycle is going to get its reserved rate, set it. Otherwise, set it to 0. And then we are going to also, there's a funding cycle flag to force claimed tokens. So this overriding flag that says, I don't care what the payer says, always send the ERC20s out to them. Never use the internal counting mechanism. So the project owner can also force that override, in which case we just want to set that here. And then some really simple accounting here. We're going to check if the reserved rate is not equal to the max reserved rate. So if the reserved rate is equal to the max reserved rate, that means no tokens are issued back out to the payer. Instead, all the new tokens are reserved. So if it's not that, then we know some tokens are going to go back to the beneficiary. The amount is the token count, and then the ratio of how many tokens are reserved, the opposite of how many tokens are reserved. And then we want to go ahead and go to the token store, which is where the token kind of logic and storage is housed, and do the mint operation. So again, funding cycle store is clocks and durations and rotations. Token store are token balances and claims of tokens. These are isolated contracts that you can't engage from the outside world. They can only be engaged from the project's current controller. For instance, I'm going to do a little detour and go mint 4. Mint 4 here, really small, but you'll notice only the controller of the project ID can make this call. And then we're going to do just some really simple balance updating. If should claim tokens, go ahead and mint directly from the token contract. Otherwise, increment that unclaimed balance, which can later be claimed. It's going, gonna go back to controller. Cool, so mint tokens here. And then we are going to add reserve tokens if needed. Yeah, so here we're going to do the reserve token balance updating, where we want to just increment and store a reference to how many tokens are reserved. So then later, anyone can come in and then say distribute tokens to reserved, and it'll just clear out this balance to all the pre-programmed destinations of reserved tokens. And that's a great way to say, like, we have a team of people, or maybe a staking contract for rewards, that we want to send newly issued tokens that we minted to existence only when the project receives new payments. So kind of issuance that's relative to the growth of a project in financial terms, but can be extended to kind of be whatever you want it to be, given the delegate pattern that we saw earlier. And that's the extent of the interaction. So the pay function is designed to be robust, flexible, but as cheap as possible. We don't want to store much information. We want to just do the necessary accounting, create space for the project to bring their own functionality and delegate allocations. So create gas space. If we keep the core functionality tight, then if we're minting tokens or doing something else, we can do all kinds of stuff in delegate allocations that projects can bring on their own. And then emit a nice, colorful event for indexers to leverage.
Nice. Okay, Django, maybe I know there's still a ton to go through, but we're at an hour and 10 minutes now. So maybe a good spot to stop here.
I think this
What?
is a great spot to stop, and I think we should do a part two, or at least have links to part twos associated with this video. We're in the process of doing a lot of these types of filming within Juicebox DAO as well. Juicecast, made by Matthew and Briley, it's a great podcast, and they've created a lot of space to do these code walkthroughs. But you can see the protocol is pretty involved. There's a lot going on. You can do a lot with it. And we spent a lot of time just creating this language that we can now use to express all kinds of financial rules and experiment with what it means to run a sustainable and powerful and kind of novel business model. But yeah, this is just the tip of the iceberg. And then obviously once funds are in, then comes the question, how do funds go out? And that would be a great topic for the next video.
Yeah, for sure. Let's schedule part two. Awesome, dude. Then thank you very much for your great explanation. It's a big system, but the flexibility is really awesome. So yeah, great explanation. And yeah, if people want to find you, what's the best place? Twitter, probably, right?
You can hit me up on Twitter at me_Jango. I'm lingering around the Juicebox DAO Discord quite a bit, in the protocol channel especially, and working on all kinds of little projects now. So a big purpose of writing the core Juicebox protocol and trying to help it get to a stable place was now we can build all kinds of fun activities and applications and ideas that really harness the system. Think like a project owner as a contract that can have, pre-programmed funding cycles that can, all right, it's going to schedule funding cycle one that has these rules, and then when a condition is met, it's going to automatically schedule another funding cycle. So you can kind of choreograph these rules over time to create applications, games, and all kinds of things. So I'm spending a lot of time now building those out. There's a lot of cool things in the pipeline. So if you come into the Juicebox DAO Discord, you may find your way into other tangent discords rather quickly that really play with these ideas instead of just focusing on these ideas themselves. Because hopefully when these work and they're steady and they're stable, there's not much work left to do here. We're not trying to ship a V4 or V5 or add more features. We're just trying to play with what we can do now with this framework.
You want to use it. You want to use it now.
Oh man, I'm dying to use it. That's it's a lot of fun. There's some really cool things headed our way, which would also be great videos. So anytime you wanna, you have like a week off and you want some crazy idea of like something we're working on that uses all these tools, hit me up. I love these calls. I love kind of diving deep, especially with folks that ask great questions like yourself, like trying to tease out the nitty gritty of like why did certain decisions get made. That's what it's all about.
Yeah, 100%, dude. I really appreciate that. So, yeah, I'm gonna link Django's Twitter, Juicebox DAO, their Discord, all of the relevant stuff, the GitHub repository, of course, in the description below. Django, thank you again. This was awesome. Thanks for taking the time. And yeah, guys, we'll see you in the next one. So take care. Bye bye.